Hey, math friends. So here's what we're going to do today. I know that a lot of you had questions about the activity for yesterday. So today is going to be just a review of that. So I'm going to walk through some examples for you, and then you're going to do some practice. So hopefully that will help, okay? So here's what we're going to do today. We are going to review the same learning target. I can describe what the scale factor has to do with a figure and its scaled copy. Now, before we start, let's review what is the scale factor for two figures. Remember, that is the number we multiply by, okay? We can't add, we can't do anything, we have to multiply, all right? So let's do our first one. What is the scale factor for this original P to Q? So I'm going to draw an arrow here from P to Q. Now, when you're trying to figure out the scale factor, here's something that you can do. Let me write it down for you. I know that I'm going to write everything about figure P under the P. And I'm going to write everything about figure Q under the Q. So this horizontal side in figure P is 3. And the horizontal corresponding side is 24 for figure Q, all right? Now, I wanna know the scale factor. So I wanna know 3 times what gives me 24. Let's write the vertical down and then we'll figure it out. So I've got 2 as the vertical here, and then the corresponding side on figure Q is 16. 2 times what equals 16, all right? Now, you can probably think about your multiplication tables. 3 times something gives me 24, and you already know the answer before I say it. But I think you're gonna notice, and I think you did notice on your practice yesterday, that some of these are not whole numbers. You're like, I don't know what I'm gonna multiply that to get a number. So here's how you could do that. Say it's not perfect. I can say 24 divided by 3, and I'll get what? 8. We know that 3 times 8 is 24, and 24 divided by 3 equals 8. This is called the inverse operation. Instead of multiplying to get an answer, we're dividing to get what we're multiplying by, okay? So 2 times what is 16? 2 times 8. So that means that 16 divided by 2 is equal to 8. So what number are we multiplying by? 8. So our scale factor is equal to 8 inches because we're multiplying inches, but it doesn't really matter, okay? All right, let's do another one. We're going to find a scale factor here, and now they are not going to multiply by a whole number. So I'm going to write my information down for P and Q. Horizontal is 6. Corresponding side now is 21. 6 times something equals 21. Vertical side is 4. Corresponding vertical side is 14. 4 times something is equal to 14. All right? So 6 times something equals 21. I don't know what that is as a whole number. There's not a factor of 6 that is, or a multiple of 6 that equals 21. So we're going to use this inverse operation. Instead of multiplying 6 times something, I'm going to work backwards. I'm going to say 21 divided by 6, and I'm going to get a number. Now, thinking back to simplifying fractions, 21 divided by something and 6 divided by something. Can I simplify that? Can I divide by 2 on both of these? No. Can I divide by 3 on both of these? Yes, I can. 21 divided by 3 is 7. 6 divided by 3 is 2. So here, 7 halves. Is it okay that I have a fraction? Yes, it is. Absolutely. Okay? Let's do the same thing with 4 times something gives me 14. 14 divided by 4, inverse operation, I'm going to get a number. It's not going to be a whole number, but can I divide and simplify? Can I divide by 2 for both of these numbers? Yes, I can. So I'm going to divide by 2. 14 divided by 2 is 7. 4 divided by 2 is 2. Check that out. It's the same scale factor. So my scale factor now is 7/2 instead of a whole number, and that's okay. Now, if you want to simplify this and say 3.5 or 3.5, you're absolutely right. Okay? Hopefully that helps some. All right, let's do one more or a few more. So we're going to do the same thing. Now this time I have an original and a copy. So up here I'm going to write O for original, C for copy. Let's do this horizontal segment in both the original and the copy. In the original, what's the length? 2. In the copy, what is the length? 2. 2 times what equals 2? I know you know the answer. Hang tight with me. Now let's do from the very top here to where the bottom is. So we're going to do this length. Did everybody see what I did there? So it's almost as if I made a rectangle around this figure and measured that part. Okay, does everybody understand that? Okay, so the original 1, 2, 3, 4 times something gives me 1, 2, 3, 4. Okay, we don't need to do any division. 2 times what gives me 2? 1. 4 times what gives me 2? 1. So my scale factor here is 1. They look exactly the same. All right. Now, just like the last one, we don't have exact values. So what I'm going to do is I'm going to highlight 2 segments. I'm going to go from A to C here, which means I'm going to go from these 2 points, in between these 2 points on this one. So let's do figure 1 and figure 2. In figure 1, the length is 2. In figure 2, the length is 6. 2 times something gives me 6. Now let's do the vertical points. So let's go from here to here and from Q to S. This vertical is 3, and the corresponding side is 9. 2 times what gives me 6? I could do this 6 divided by 2, and I can get a whole number, 3, or I just know that 6 is a multiple of 2, so 2 times 3 is 6. 3 times 3 gives us 9, so our scale factor is 3. I hope, guys, that this is getting easier. This last one I want to do with you is when it gets smaller. So this is going to give us a fraction for sure, because this times 1 would give us the exact same figure as we just saw. Okay, so original, copy. The original horizontal, I like to do that one first for whatever reason, is 5. The copy horizontal corresponding side is 1. 5 times something gives us 1. Now the original vertical, 1, 2, 3, 4, 5. And the vertical for the copy is 1 again. Okay, so 5 times something gives me 1. I know this is not a whole number, so let's use that inverse operation, division. 1 divided by 5. Well, that's just a fraction 1/5, right? So 5 times 1/5 gives me 1. 5 times 1/5 gives me 1. And let's think about this, guys. If I have the number 5 times 1/5, remember when we multiply fractions, we multiply numerators and denominators. 5 over 5, that would give me 1. So 5 times 1/5 is 1. All right? So what I want you to do today as your practice, you guys are going to not really sort, but you're going to find the scale factor for each card. okay? Now, if you have an odd figure like this, I would measure inner parts of it. We know that they're all scaled copies, so you don't have to measure every piece of it. Just pick 2 corresponding segments and measure those and find your scale factor. Now for card 3, I would measure from maybe, 2 points here, or make a box around your figure and measure that way, okay? Does that make sense? I hope that makes sense, okay? That way you have a rectangle to measure. So it would be something like this, all right? And you would measure those 2 pieces. For the circle, I would measure across the circle, okay? And for these, you can do those because they have clean edges, okay? So you're gonna find the scale factor for each of these. So on your paper, I should see scale factor equals something, scale factor equals something, okay? It can be a fraction, that is okay. Now, the very last thing you're going to do, once you do 1 through 8 and you find the scale factor, I want you to just write which cards have a scale factor less than 1 and which ones have one greater than 1. Now, a number less than 1 is going to be your fractions. So you might have card 1, 3, and 5, and card 2, 4, and 6. And that's all you have to do for your activity today. And we will go over this tomorrow, all right? If you have questions, don't forget to email me, Canvas message, text, whatever. All right? I hope you have a great day.